Okay, guys, so in this lecture, we're going to do a brief review on what we discussed last time regarding polar accelerations, and then we're going to do a few examples on that. Okay, so this is the idea here. If you, we were looking into different ways for calculating the accelerations, right? We looked into, the Cartesian accelerations, where, the position, acts as a function of time, right? Y is a function of time. We looked into, kind of path specific acceleration, where we know where the acceleration is a combination of, the tangential acceleration and also the normal acceleration. Last time we looked into another way, which is basically using the polar coordinates, right? And we said I can also express the position of a particle or a point where I'm trying to find its acceleration based on an angle r, the radius r and angle theta, right? And we said basically I'm going to have my UR and my U theta. How would my U theta look like? U theta is going to be in the same direction as theta, right? U theta will be in the gross direction of theta. So this is my U theta. Okay, so now I can basically write my R vector or the position of this particle, right, in terms of R as a scalar and theta. So R is equal to R times UR, right? R, so usually we don't know R as a vector, we know simply R, the length of this line basically, but we know the UR direction. So R, UR, right? If I want to find the velocity, I'm going to differentiate this guy, and then when I differentiate this guy, it is a compounded differentiation. So it will be R prime UR as both plus R DUR dt. Okay, and we said last time that DUR dt is going to be equal to theta prime as both times U theta, and we also said that du theta dt is equal to minus theta prime UR. You should just know that. I mean, you don't need to know how they are differentiated, how they are obtained. If I continue this, basically, what would my velocity be like? My velocity is going to be equal to R prime UR plus R DUR dt, which is R theta prime U theta. Okay, if I want to get the acceleration, I will differentiate this guy one more time. And we said the acceleration ultimately is going to be equal to what? If you continue to differentiate this guy and then you apply DUR dt and then the other dt to be these guys, you will end up with what? R double dot minus R theta prime square UR. So this is the acceleration component, or this is the magnitude of the acceleration along UR, right? And then we have the magnitude of the acceleration along U theta. If someone remembers, it will be equal to R theta double dot plus 2 R prime theta prime. So make sure you get yourself familiarized with this equation very well. This is a very important equation. It only has 4 terms basically. This is the radial acceleration. So how R double dot is increasing, or how the acceleration of the actual line, minus R theta prime square. This is a centrifugal acceleration on Masboot. So R double dot minus centrifugal acceleration. If this guy was going along a circle, R double dot would be 0. So you only end up with a centrifugal acceleration, which is already expected. On the other end, tangential acceleration, the first term is going to be the tangential acceleration plus 2 R prime theta prime, and then we said this is a Coriolis acceleration. So if this guy was moving along a circle, can someone tell me what 2 R prime theta prime would be?
0.
0, exactly. So you would only end up with R theta double dot, right? Which is already expected. Okay. So make sure you know this equation. If you want to kind of venture into it in more detail, I recommend that you look into the derivation of it, really understand where it came from, how it came about, really understand that acceleration is a derivative of the velocity as a vector, right? Not as a magnitude, right? And then because these UR and then U theta are changing as a function of time, they are not constant. So if I differentiate a vector that is changing, then you have to update it by whatever its value is. Okay. So this is really it, guys. Okay, this is all that we have to know about this portion of this chapter. So what I would like to do today is let us, venture and then try and then solve a couple of problems on it. I think this is the best way to learn is by doing examples. Okay, and those of you guys who want to really excel in this course, you want to do as many examples as you want, as you can, basically. So this is the book explanation of it, right? So we have a curve, right? We have R, we have UR, and then theta. We know R is going to be equal to RUR. I can then obtain my velocity. I can differentiate this guy, right? Then this is going to be my velocity. Ultimately, V is equal to R prime UR plus R theta prime theta. So you have a component of the velocity which is along the radial line, because the radial line is actually changing velocity, right? So you have to incorporate that in your equations. And as a result of theta, basically, you will also have some velocity in the tangential direction. Here, tangential direction, it's not tangential along the curve, right? It is tangential or basically perpendicular to the radial line, okay? So what some people make a mistake, basically, they would assume that theta is going to be tangent. Ultimately, your V vector will actually, it must be tangent to the path, right? After you calculate that, basically, the velocity would have to be tangent to the path. Regarding the acceleration, we have a radial component of the acceleration, and then we have a transverse acceleration. Okay, we can also call it transverse velocity instead of calling it tangential velocity. Called transverse velocity and then radial velocity earlier. All right, guys. So what I would like to do is let us work on this example here. And in this example, basically, we have a small washer that is sliding down the chord OA. And when it is...
we didn't do the 3D part yet.
We didn't do the 3D part, yes, but well, guess what? Okay. Here, UR and theta are vectors that are always actually in the horizontal plane. Let me draw this for you. So here, okay, this is my R. This is my UR basically here. And my theta is going to be like that. Okay, so this guy here, let me write that for you. This is my UR. Oops. Okay, I don't really use that much, but I'm not sure why it's copying this number. See if I can erase that. Okay, I can erase it. Okay, so this is my UR here. Okay. Can I move that? Maybe I can move it. No, I can't. Let's try this. Okay, here we go. So this is my UR. Now this is my theta. Can you help me? How can I establish a third dimension? U theta. Okay, if you have that basically, then I'm gonna simply add a UZ basically. And UZ is not gonna be anything. So UZ is gonna be simply a unit vector in the Z direction. Okay. Okay, let me do that. So UZ, here we go. Okay, if I wanna do a third coordinate, I'm gonna actually redraw this one more time. So if I have X, Y, and then Z, then this is my R. If this is theta, guys, can someone tell me how would the U theta look like?
Towards Y?
Exactly, in the same direction as theta. So be very careful about that. So this is U theta. And then UZ, guys, will be independent. So UZ, it will be independent. So if I have a velocity here, right? So if I have a starting from R, right? If I have R is equal to R, UR, basically, I will simply add to it Z times UZ. Does it make sense? Basically, the vector is going to be R plus whatever value I have along the UZ, right? And then when I'm differentiating this guy, UZ is not changing direction. Only UR and U theta are changing direction. So what happens here? So this guy, I'm simply going to add to it Z prime UZ. Okay? And then here, I would add to it what? Plus Z double dot UZ. Why? Because UZ is not changing direction. So if I'm differentiating UZ here, it will be simply be Z prime UZ, Z double dot UZ. Okay? That's it.
كيف ما فهمت أنا. كيف that is not changing direction؟ مش هيدي هي عم تنزل، مش هيدي الرينج عم تتغير ذات تبعها.
Right. The z is changing direction, but the uz is not changing direction. The vector is not changing direction.
اوكي.
Okay, the vector is not changing direction. Okay, let's actually solve this problem. In this course, we're not going to be dealing with three-dimensional, movements. We'll only be dealing with two-dimensional movements. But this example is here just to show you that uz actually doesn't change direction. Okay, so we have this small washer, and we're trying to express. So when it's at the midpoint, the speed is 28 meters per second, and the acceleration is 7 meters per second squared. We have to find the velocity and acceleration in terms of the cylindrical accelerations or cylindrical coordinates. Okay, so we have v, okay, is going to be equal to r prime ur plus r theta prime u theta plus z prime uz. Okay, can someone tell me how can I actually get that? How can I do this basically? So basically I have this vector here and I'm trying to express that. Okay, let me draw this again here very quickly. So we have, this is point A, and then this guy is somewhere in the middle. This is my velocity. Right, and then let's do this. Let's say this is my UR. Let's say this is my U theta.
بس here you are و you theta مش they are not changing كمان إنه إذا to the origin.
Yeah, well, this is what I want to ask you guys. So, what is theta prime, by the way, in this example?
مش zero.
Exactly, theta prime is 0. So we have no components along U theta. So the only components that we have are going to be along UR and UZ. Correct? Can someone tell me what is the UR component of the velocity? How can I calculate that? Well, I know this distance here is 2. This distance here is 3, right? And then this guy is 6. How can I find the UR component of the velocity vector? Can someone tell me what would that be?
Can we use the Pythagoras Theorem?
Uh-huh.
We find أول شيء تحت radical of c squared plus 2 squared. Then we do radical of this squared plus 6 squared and we get OA. Then we take the unit vector of it.
Okay, so let's see. I think we need this angle, right? Can we call this angle alpha? If this angle is alpha, right? Then what would be the UR component of vector V?
OA sine alpha.
OA sine alpha, لا بدك OA. OA is a distance, right? Come on, guys. I'm sure some of you would know this. What is the projection of this vector, of the velocity vector along UR?
Minus v cosine alpha.
Exactly, minus V sine alpha مظبوط UR. You guys agree? Right? So
yes.
Minus V sine alpha in the UR direction. How about along the UZ direction?
Minus v
Cosine
cosine.
alpha UZ.
UZ. Okay. So it's okay. So that's it, right? What is the value of V?
28.
28, right? What is alpha? How can I calculate alpha? Okay, what is this guy here? This guy is square root of 2 square plus 3 square. مظبوط؟ ما هيك ولا لا؟ This lands here, right? This lands here is square root of 2. Okay, so what is tangent alpha? Tangent alpha is equal to what? Opposite over adjacent, right? So square root of 2 square plus...
دكتور ما عم بفهم شو هي اللينث اللي عم تحسبها.
This length right here. Right? I need to get alpha, right? I know this guy is perpendicular to this, right? So this guy is 90 degree, مظبوط. This length right here is square root of 2 square plus 3 square, right? This length here is equal to square root of 2 square plus 3 square. مظبوط. If you consider this triangle, you're going to get this guy, right? So square root of 4 plus 2 plus 9, right? So which is square root of 13, right? over 6. ما هيك tangent alpha is equal to opposite over adjacent, right? So alpha is equal to inverse tangent of square root of 2 square plus 3 square over 6. So now you have alpha, and then you simply plug it here, right? You are minus 28 cosine alpha UZ. Okay, if you guys want to do these numbers, I'm not gonna like sit down and do all these numbers, but this is your value for alpha. So you just simply plug it here, and then you get V as a function of UR and V as a function of UZ.
31 degrees alpha is
How much?
31.
Okay, thank you very much. So 21 degrees. So your velocity is equal to minus 28 sine 31 UR both minus 28 cosine 31 UZ. Okay, deal. How about the acceleration vector?
دكتور بس قبل ما نوصل على الاكسلريشن عندي سؤال عن الفي.
Yeah.
السبيد هي 28 على الميد بوينت بس. كيف اخذناها نحن دائما 28 السبيد؟
Okay, so okay, the speed here, right? When it is at the midpoint, that is the speed, right? So we're trying to find the velocity at the midpoint. مظبوط؟ وهنا
اوكي يعني نحن عم نلاقيها على نقطة واحدة الفيلوسيتي، ما عم نلاقيها على along the as a function of t مثلا.
It's independent of anyway, right? It's
okay.
velocity vector is in, so whatever the velocity vector, even if it's at A, then that would be here. مظبوط؟ We are simply projecting هذا velocity vector على على these unit vectors, right?
Yes, صح 100%.
Okay, very good.
Thank
How
you.
about acceleration? How about the acceleration, guys?
بس دكتور هون معنا انجل ما هيك ثيتا.
No, ما عندنا انجل ليه؟ لانه this angle theta is not changing. مظبوط؟ اذا قلت لك point A مثلا عم تبرم على circle فوق، مظبوط؟ then it's a different story. Right? But one point A is not changing. So theta is not changing. Come on, guys.
We use the formula.
Okay, but the formula تبع A كمان theta prime is 0, right? So here basically I'm providing you the acceleration directly. مظبوط. All you have to do is project the acceleration على هذا الcoordinates. مش هيك؟
V prime.
Okay, what is the acceleration, guys?
V prime.
Okay, V
بس
prime.
الفاكتور يعني.
لحظة شوي. V prime is gonna be 0 هون مش هيك ولا لا؟
صح مش نشتغل على الايكويشن تبع الاي لانه ايه صح لانه الفي مش as a function of time او شيء. لازم نشتغل على الايكويشن تبع الاي معنى اياها.
Okay, طيب. Okay, let's say ما نشتغل على equation تبع A. What is the equation of A? So R double dot مظبوط minus R theta prime square UR مظبوط plus R theta double dot plus 2 R prime theta prime U theta plus Z double dot UZ. ما هيك؟
U theta بتروح.
U theta بتروح. Okay.
والثeta prime بالاي باليو ار بتروح يعني تصير بس R double prime.
Okay. So you end up
بيبقى عندنا R double prime UR و plus Z double prime UZ.
Okay. Very good. Okay, هلا شو؟
فينا نعمل لها projection مثل ما عملنا للفي نفس الشيء.
Exactly. This is what I wanted to see. Yes, exactly. So you already have a value for the acceleration. And no need for you to actually look into these what are double dot and so here is basically it's going to be simply equal to what? Minus 7 sine 31 UR, right? So basically you simply want to express the acceleration vector which is given to you linearly and then map it into the coordinate frame and then you are done. Okay, minus 7 what? Cosine. Check cosine 31.
Yes.
Okay. So minus 7 sine 31 UR minus 7 cosine 31 UZ. And that's it, okay? We're done with this problem.
بس ليش minus؟
ليه minus? You should tell me why is it minus? No, it is when at the midpoint. Yeah, هن basically يعطينك الvector هون. It's coming toward the origin, right? So if you look at this figure from top, you will see that this vector is pointing toward the center. It's pointing in the opposite direction of UR.
فيك ترجع تعيد لأنه فصل عندي الكونش.
Okay, so هون يعطينك الvector is in that direction. مظبوط؟ If I look at this figure from the top, هيدا vector is going to be pointing toward the origin.
Yes.
If it's pointing toward the origin, it's pointing in the opposite direction of UR.
اوكي.
Does this make sense? Okay. Okay, guys, very good. So let me clear this up here and then jump into. Okay, so this is basically where we use these guys. Okay, let's work on this example. All right, in this example, basically, we have Haider rod OA. Okay, it's rotating counterclockwise with a constant angular velocity of 5 radians per second. 2-pin connected slider. So we have this slider basically is connected to this rod basically, and as a result of the movements, basically, it's following a radius about this. The radius of this object basically is provided to you as 100 multiplied by 2 minus cosine theta, and that is in millimeters. We would like to find the speed of the slider of this block basically at the instant of theta equal to 120 degrees. Okay, so let me kind of redraw this here. Okay, so this is what we have. So we have, this object, right? And then we have the slider basically, right? And theta is given to you like that. And we know basically the length of R here, right? What is the length of R here is equal to 100 multiplied by 2 minus cosine theta. Okay? And they told you that
الار هي او بي.
they told us that theta prime is equal to how much? 5 radian per second. Okay,
بس دكتور فيني اقول الار هي او بي.
الار هي او بي. Yes, it is. Yes. So this is point O, and then this is point B. Okay, so we're trying to find the speed at 120 degree. How can I do this?
We can use the formula for V.
Bravo. We can use the formula for V. Exactly. I like this answer. So V is equal to R prime UR plus R theta prime U theta. Okay, very good. So here R prime is the rate of change of R as a function of time, right? And theta prime here is theta prime as a function of time. So how can I find R prime? I actually have R. How can I calculate R prime?
Isn't it 0?
مش minus 100 cosine theta.
We integrate theta prime.
لحظة شباب.
فيني نعمل chain rule.
I have to use a chain rule, exactly. So R is given to you as a function of theta, right? Okay. So R is given to you. So if you want to get R prime, right? How do you calculate R prime? So you differentiate by theta and then you multiply by theta prime. Okay. What is the derivative of this guy with respect to theta?
minus 100 cosine theta. minus 100 sin theta. لا 100 sin theta. 100 cosine minus صح.
100 sin theta multiplied by
theta prime. Theta prime.
Okay. So this is a function of theta. Okay. So every time you differentiate this guy, you want to make sure you multiply by theta prime, right? In other words, why is it like that? So if I actually do dr, only dr, I'm gonna end up with what? 100 sin theta multiplied by theta.
بس دكتور انت هون الار برايم قصدك فيها دي ار اوفر دي ثيتا صح؟
No, here dr over dt. When I got v, basically here r prime is the rate of change of r with respect to time, not theta. Okay. So,
بس اذا عم بعمل دي ار اوفر دي تي لازم يطلع كونستنت يعني الرقم كله تايمز تي تايمز.
okay, so r is given to you as a function of theta, right? So if I do dr, and theta is changing. So if I do dr, I'm gonna end up with 100 sin theta times d theta. You guys agree? Okay. If I actually do, dr d theta, I'm gonna get 100 sin theta. But that's not what I want, right? I want dr over dt, right? So I'm gonna differentiate this guy also by dt. So which is 100 sin theta d theta over dt. مش هيك من هون اجت theta prime basically. This is called the chain rule, right? So r prime is equal to 100 sin theta multiplied by theta prime. Is that the deal, guys? Okay, so r prime is given to you here. Theta prime is what? D theta as a function of time. So let's redo this, right? Okay, so what is my velocity again? R prime, which is 100 sin theta multiplied by theta prime, UR. UR plus r times theta prime. What is r in this case? R is 100 to
100 2 minus cosine.
minus cosine theta multiplied by theta prime times zeta.
Doctor, I have a question.
But one second, let me just finish that so we are all clear on here. Okay, so they ask
Okay.
us the velocity when theta is equal to 120 degrees. So how can I go from here?
We have theta prime as a constant,
Okay,
and they gave us theta,
we know theta prime is equal to how much?
5 radians per second.
Per second, yes.
And then theta,
وبنحول تاتا ومريدين.
how much theta?
We can find r from the formula. R equals 100 times 2 minus cosine theta, and we replace theta by 2 pi over 3.
Yep, there you go, 2 pi over 3 radian. So I'm gonna find my velocity is gonna be equal to 100 times sine 2 pi over 3, multiply this guy by 5, UR plus 100 2 minus cosine 2 pi over 3 multiplied by 5, and then this guy is theta. So you calculate this, you calculate that, and then ultimately you will be able to find the magnitude of the velocity. Okay, does anyone want to do this, or should I do it here on my end? So sine of 2 times pi over 3, multiply that by 100. How much you get? You get 3.65. I have to multiply it by 5. Okay, so I'm getting 18.27 along UR. And then if I do this guy, what am I going to get? Let's see, cosine of 2 times pi divided by 3. So I do 2 minus this.
It's 500.33.
You got it, exactly. So I got the same number. So 500.33 Utah. Can someone tell me what are the units for the velocity here?
Can you repeat the question?
Can someone tell me what is the unit of the velocity?
Is it millimeter per second?
Bravo, yes, exactly. Millimeter per second. Why millimeter per second?
Because r is in millimeters.
Because r is in millimeters, exactly. Okay, very good, guys. I have another question for you guys. If I want to find the I and J component of the velocity. So when we have the velocity given to us in terms of UR and d theta, right? If I ask you to find the velocity in terms of, I and then J, how can you calculate that? Is there a possible way, do you think, we can convert between, so we said, if you have an angle theta, right, this is my UR, and this
إذا عملنا اليو ار اي والجي ويو ثيتا اي والجي ونجمع الايات لحال والجي لحال.
Bravo, exactly. Yes, exactly. This is exactly what we're going to do. But how can I convert between UR? How can I express UR in terms of I and J?
It's cosine theta.
We use sine as
A with the angle.
There you go. So UR is equal to cosine theta I plus sine theta J, right? How about U theta? Can someone tell me what is U theta? How can I find U theta? Okay, does anyone know what this angle here is equal to how much?
90 minus theta. 180 minus 90 minus
Okay,
theta.
what is this angle right here? That makes a vertical with U theta. What is that angle?
هاي مشان تكون 40 لا مش شرط لا
90 minus
Sine.
theta.
If theta is 0, this angle is going to be what?
If theta is 0.
0.
If theta is 0, yeah. So this angle is theta, right? Maybe I should draw it on a bigger figure. Draw it here. Here we go. So this is my UR, and this is my theta, right? If this angle is theta, right? If I actually have a vertical, then this guy is going to be theta. You guys agree? If theta is 0, then this guy is 0, right? If theta is 90, this guy's going to be 90. Okay, so how can I express theta in terms of I and j?
هيدي cosine theta minus sine theta
Okay, what is the x component of u theta?
minus sine theta.
Minus sine theta, exactly. So this is minus sine theta I
وهديك cosine theta.
plus cosine theta j, exactly. So if you want to express the velocity in terms of I and j, so you take ur and then you plug it here, you plug this guy here, and then you take u theta and then you plug this guy here. Okay, by doing so, basically you can get the ur and u theta values of the velocity. Okay, guys, so that is it regarding how we can find the velocity. So we're done with this problem. Let's jump into another problem.
Doctor, I have a question
Yeah, sure.
about if we need to integrate with respect to time or derive with respect to time, could we have integrated theta prime with respect to time and then put this in the r equation and then directly derive r with respect to time?
Okay, well here you have a constant angular velocity of theta prime. If you integrate theta prime, you're going to get, well, you can't really. You basically, you have here r as a function of theta. So for you to be able to get the velocities, you will literally have to apply the equation that you have here, right?
Yes, I didn't mean in this example specifically. I meant if we had like the time.
Okay.
Could we have done this?
If you have the time, you want to integrate theta?
Integrate theta prime and then replace
I'm asking you
theta
for
in the r equation.
I'm asking you for the velocity. Why would you want to integrate theta prime? If you want to integrate theta prime, basically you will simply find, you know, how theta is changing as a function of time.
Yes, if we had like we needed to find r at 5 seconds, for example.
Okay. Yes, you can, exactly. So if you want to be able to find it as a function of, if you want to calculate r, yes, but this is not what I'm asking you here. Right here, all I'm asking is just simply find the instantaneous velocity. Right here, we're simply finding the instantaneous velocity, you know, at this point, right? For this configuration, at this point, for theta equal to 120 degree, tell me the instantaneous velocity. Later on, what you will be able to do, you'll be able to find the velocity as a function of time. Right, so you can turn this guy into as a function of time, and you can do all these guys as a function of time. But obviously, you would need to have theta as a function of time. And once you have theta as a function of time, you can, and you need to get all these basically as a function of time, and then you can do that as a function. But this is beyond the scope of what we're doing in this chapter. Okay, so just understand how to apply what I have here, and then that's it. Okay, guys, so this session is going to be done. So what I'll do is let's hang up now, and then let's open another session to, you know, work on one more problem, and then call it a day. So I want to stop it here right here.